Hi guys, so this is a new series on calculation of bond energies, energy changes generally. So one of the calculation on energy changes is bond energies, and here we've been given the bond energies of these bonds. Hydrogen to hydrogen bond, that's 432. By the way, the units here are in kilojoules per mole, all of them. So given all this, we are supposed to calculate the enthalpy change of the reaction, this reaction right here. I just wrote delta H here, but these values are the bond energies, okay? So now if you want to do that, the first thing you need to know is that the bond energy can be used to calculate the enthalpy change of the reaction. And then the enthalpy change of this reaction would be delta H of the reactants minus delta H of the products. Now at this point, I'm sure you might have been used to most of chemistry calculation having products minus reactants. But in this case, this is different because in your reactants, that is where you're breaking bonds and then you're forming bonds in the products. Okay, so that is why we are having reactant minus product. So it is like saying bond breakage, which happens in your reactant, minus bond formation. That gives you the delta H. Okay, so applying that for this question, this is like saying that will be equal to the delta H of, let's analyze our reactants now. But before we do this, we have to draw them out. It's very important that you draw it out. So let's draw out our hydrogen. Hydrogen is this way, H to H. And then our fluorine is a bond like this. And then on the other side, we have hydrogen fluoride. That is like this. We have 2 moles of this, so we have to consider that. Right, now with this, we can see here that if we want to calculate our delta H, it's going to be delta H of H to H plus delta H of F to F bond. That's the bond energy of F to F bond. And then we would say that minus the one for our products, which is HF. So now we have 2 moles here, so we have to consider that and then multiply by 2. So this is 2 times the bond energy of F to F bond. Okay, so 2 multiplied by that. Right, so putting all this together, this is 432 plus 154, then minus 2 into 565. If you calculate all of this, you're going to have the enthalpy change of the reaction to be minus 544. And then you put the units there, and that is how to solve it.